Three, two, one. Okay, we're alive. Welcome to the Hiking with Swift channel. And this should be my first tutorial video. Hopefully the first one of a very long series. So today we're going to make a one-time code boxes using SwiftUI. So the reason I made this video is because I was looking for something like this with SwiftUI, but couldn't find one. So I had to build one from scratch, and it worked out pretty well. So I feel it may be worth sharing. So what we're going to make today is something like this. So this is a two-factor authentication screenshot from appledeveloper.com. And you can see it has 6 boxes, and you can paste the code you received from your text. And so we want to achieve basically exactly the same thing. So we want to make a one-time code widget like this, which can have different digits. Like sometimes we have 6, sometimes we have 4, and in weird cases we may have 5. So we just want to change a parameter and change the number of boxes. Also, we want to support paste code from SMS or just paste code from anywhere, but we want to support this. And also we want to make like typing 1 and then the cursor automatically jump to the second box. And if you delete, this cursor will jump from second to first. Yeah, that's basically the idea. So it works like this: 1, 2, 3, delete, delete, delete. Let's try if I can paste something here. Just paste 3. Paste. Yeah. So you can even paste in 3. Like I can type in 1, 2, and then I paste. Yeah, and I'm not typing in the last one because once I type in the last one, it will try to log me in, which this code is not correct. So I'm just using this to demonstrate what we're trying to achieve here. Okay, so you will be watching me create this thing step by step with SwiftUI. And let's get started. Okay, let's begin with me showing you how the completed widget works. So we can start typing, and we can delete, and we can paste in, and we can only paste certain digits. Paste. Yeah, so it works like this. And we can easily change a number here to change the box numbers. So you can see 4, and it's 5. Yeah, so it's very flexible. Okay, so let's start from scratch. I have created a new SwiftUI app, and it's pretty basic. So there's the entry point, and I didn't even bother to change the content view default name. And what's in the content view is a vertical stack with some basic text, like a large title, and this text field is supposed to be a placeholder. Later we can replace with our one-time code boxes, and a button recent code. I just have something to show so the UI doesn't look too boring. And also you will notice I've added 2 string extension methods. So nothing too complicated. I'll cover them when we actually use them. Also a folder to contain the things we're going to make. So this one is a SwiftUI view. So this, you realize like the name is called boxes. So it's a collection of the boxes. And another one, code, one-time code input. This represents one box. So this is the SwiftUI view, and this is one box, and this one we're actually going to use the UI view representable to wrap a UI kit text field. Because, okay, the reason we want to use UI view representable to wrap a UI kit view is because we're trying to achieve this typing one and jump to next thing. And this is not very easy in SwiftUI, because this requires you call something become first responder. But SwiftUI doesn't even have a first responder property or anything. So we need to use the old UI kit stuff. So that's the main reason. So after we analyze the model and what we're trying to achieve, we need to decide what approach we're using. So my approach is we create a wrapper for a UI text field and then use it in this SwiftUI view. Okay, so that's the step one. Also, we can also analyze the one-time code. So let's say we have 6 code, and a good data model to represent this will be a dictionary, because if it's an array, then this can be empty and this is filled, this is filled. It's hard to represent using an array, but if with a dictionary, you always have 6 keys, and the value can be an empty string, but you will always have 6 key value pairs. So that's why I decided to go with dictionary. So let's start creating those data model, or we can call them states. So let's start with state, call it code dict. So this should be an integer and a string. And to create this, we want to have code digits. So let's say it's 6, and we need a beginning value. So I'll use a dictionary initializer, integer, string, and I'll use this one. So this initializer takes a unique keys with values. It takes a sequence of tuples. So how do we create those tuples? I'll just use a mapping method, 0 to code digits. So this is 0 to 5, and then I map into a tuple, and start with empty string. Okay, this looks good. So we can delete this. Let's Xcode to infer what the type is. So the type is a dictionary with integer and string. And this may be a little bit confusing, but what it looks like is actually this. 1, 2, well, you get the idea, until 5. Yeah, this is this code dictionary. And we want to start with this, and then every time we modify this, we change, oh, this should start with 0, yeah, 0, 1. So each time we change in this box, this value will change, And the second one, this will change. So that's our model. And let's also create a state first responder index and start with 0. So we will use this to jump forward and backward to represent the first responder index. Okay. Well, now we have the states, and we finished the step 1. We're going to step 2. And this is the most fun part. So because this will compose this one-time code input to use 6 or 4 of them. So we can't start doing this without having this first. So I commented this out to make the code compile. If I uncomment them, immediately you will see this struct doesn't conform to this protocol. So I can add protocol stubs, which just add me this one. Well, that's helpful. I'll just say UI text field, because I'm wrapping a UI text field inside this, and it's still complaining. And I noticed if you click this again, it doesn't help you very much. It just adds this thing again. This is not what we want, but fortunately I know what are the required methods. So I just add some comment required methods. So first we want to make UI view, and second one is update UI view. And those are two very basic requirements. So you can see the warning, the error went away. So here we want to create a UI text field and return it. So we can just do this. And but we do want to configure it a little bit. So that's why we create first UI text field and return UI text field. And then we do some configuration. So keyboard type is number. We only allow entering numbers. And content mode. Oh no, text content type should be one-time code. So setting this will allow you to copy code you received from messages, SMS text. So that's this thing. Magic for this thing. And we also want to configure the font. Let's say large title to make it large. And using this, the benefits of using this is dynamic type. So if the user makes the font larger, your box will also become larger. And what else? Alignment. Text alignment. Let's make it center. Yeah, that's what I can think of. So we can add more things later, but I think this looks good so far. And update view. This is the method we use the states we pass in. Well, I haven't added, but I'm going to add it now. So we're going to pass these down, like pass it into here and then pass it down to each box. Of course, it's no longer states, it's just a binding. And so it's binding and it doesn't have default value. It should be an integer string. And this is binding. So it's integer. And we use these states to update the UI view. So I also need to pass down an index of this box, because this box needs to know its own index to update its text. So here is where we do that. When this state change, we update the text. So we will say UI view, which is the UI text field, text equals to code dict index. And also, if index equals to first responder indexed, we become first responder. Okay, that's the basic requirements. This method is a SwiftUI view trying to update the wrapped UI kit view. And but we also want to let the wrapped UI kit view talk to the SwiftUI view. So to do that, to do two-way communication, we need to, if we only need one-way communication, this is good enough. But to do two ways, we also need to use a coordinator. So just mark it as internal type and coordinator and as object. And suddenly you see it giving me error again. Because if you want to use a coordinator, you also need to provide a way to make coordinator like this. Okay, now the error is gone. So the coordinator is where you handle the UI text field stuff. So I will make it conform to UI text field delegate. And so here I need to set up the delegate as a coordinator, a context coordinator. Okay, looks good so far. So let's keep going. Now our one-time code input conforms to UI view representable, but our coordinator is an empty class which does nothing. That's not what we want. So I'm going to add some UI text field delegate method. Text field should change, like, yeah, this long one. I'll just do some indentation to make it look better. Okay, so this method gets called like when the UI text field text is about to change, and it asks you to return a bool value to indicate if you want to allow this change. So this is called when I type or when I paste something into the UI text field. So here, first of all, we want to always return false here. Why? Because like that's the point of using SwiftUI. SwiftUI use states to manage the UI controls, and so if we return true here, we will allow the text field to change its text by itself. But we don't want to do that. We want to change text by modifying the states. That's why we always want to return false here. So we will have a single source of truth, which is our states. So we return false, and we can modify this manually to update the text field text. So return false. That's the very basic requirement. So in all passes, we always return false. And so here, we will be handling 3 scenarios, which is this. So if you think about it, when we're doing things here, so we can type, and we can delete, and then we can paste. That's all the possible cases. So we're going to handle that inside this delegate method. So within this method, what you 99% time you want to do is to first you got current text from the text field. Text, you can force unwrap, but if you don't like it, you can use this too. And then we also want to get the range of the string about to change. Like it gives you this range, but you also need to use this NS range to create a range. So let's say range, NS range inside the string. So we pass in this range, and in string is the current text. Current text. Else we just return false. Always return false. So then we find the string range. String range is about to change, and then we can say updated text equals to current text, replacing characters within this range and with this replacement string, like incoming string. If I'm pasting, and the string I'm pasting is this, and if I'm typing, and then the string I'm typing, which will only be one character because you can only type one character at one time, it will be this. So we replace the range should change with the incoming string. We get the updated text. So this is what you usually would do with a text field, but our text field is a little bit different. It's a one-time code box, so it will only have one letter, one number, and then it should jump to next. So I just wrote this because 99% you will use them. I just write them out, and if later I don't need them, I can delete them. So we need to handle three possible cases. One is typing. Typing. Two is pasting. Three is deleting. Okay, so let's start with typing. So as I just said, if string count equals 1, then this is typing. If we're typing in one character, then we just want to update the state. Say update value. The key is my index. Like if I'm this text box, I have index 0, and then I only want to update the state's key 0. So, but now it's giving me warning, say, this code dict is inside this struct, but not inside this coordinator. I cannot use this. So I need to pass it down into the coordinator. So let's do that. Let's pass this down. I think I need both. Yeah. Okay, so this is gone. We have the index, we have code dict. But now it says it has no initializer. Well, classes, they're not like struct. You don't get free initializer. So we just create our own, and index integer and code dict. This would be a binding of a dictionary. Okay, so self index equals index self underscore, because it's a binding. I use this underscore to initialize. Okay, now this area is gone, and now it's complaining here because when we make it, we need to pass in those. So we just pass it down there. And to pass a binding, we use a $sign. Okay, now all error is gone. We can continue here. So if I'm typing one character, I just update that character in the dictionary, which is string. Okay, that's pretty easy. So pasting. So if string count is bigger than 1, so in this case, if I'm pasting in 3, so I can start pasting at any index. I can paste from here, I can paste from the index 1. So I need to like do a for loop through the next 3 boxes, and then update its value. So I need a for loop for in. So, and this for loop should start with the index, because I don't want to loop 0. I want to loop 1, 2, 3. So starts with index, and should be smaller than index plus count. So it should be smaller than this, index plus count. Also, if we paste in like 7, 8 digits, we don't want to go beyond the boxes. So we need to calculate a min number here. So we want to calculate min number, and so we don't want to go beyond code dict count 6, and that one is index plus string dot count. Well, it's a bit confusing, but you can, if you think it slowly and carefully, you will figure out this loop. So I can delete this. So I start from index 1, and if I'm copying 3 characters, this will be 1 plus 3 is 4, and min is 4. So 1, 2, 4, 1, 2, 3, 1, 2, 3. Okay, feels right. Well, I could be wrong. If I'm wrong, and I can come back and fix this later. And let's also think about pasting in 7 digits case. So I'm pasting 7 digits, then this is 7, and I want to use a minimal one, so this will be 6, and so from 1 to 6. Yeah, seems correct. So for this, I want to update its value, the code dict update value, and the key is this index, and the value is string, something like this. But well, string doesn't take integer as subscript. You have to pass in like string index. That's where my extension method string at index comes to help. So we can pass an integer to get the character at that index. So, but here we don't want to always get 0. Well, we always want to start from 0 and then we go up. So from here we get the 0 index, and here we get the index 1 of the pasted string. So here we need to do this I minus index, I believe. So let's think about this again. So I'm here, and my index is 1, and I start with 1, and 1 minus 1 is 0, string at 0, 1, 2. Okay, looks good. So this is how we update the state value when we are pasting. And I think this pasting, this loop, also covers this typing. like because if string count is 1, then I just do indexed index plus 1. So I loop 1 time and then update the value. So yeah, these two can be, this two scenario is actually one scenario. And so we can do this. Okay, looks good. Okay, so now we've handled two scenarios. We want to continue to the deleting scenario. So how do I detect if I'm deleting a character? So I will check if the incoming string is a backspace key. So if string is backspace, this is another extension method here. So basically I detect if it's a backspace key and I return true or false. If it's backspace key, then well, what should happen is I should delete this character. And because we're returning false in all paths, I need to do it manually. I need to update my state and the index, and I need to set it to empty string. And I think that's it. That's a deleting scenario. But we've missed something. That is, like when I type in here, and after I type in one character, I should jump to the next box. And when I delete, I should go back one box. So I need to also modify the first responder index here. But I need to pass it in first. So let's pass it in, and first responder index. It's a binding integer, self underscore first responder index, and then we need to add it to the initializer, and we just pass this down. Okay. Okay, before I add that, let's move this up, and if it's backspace, we just return false, because if it's backspace, then we're not typing or pasting. We can just update the value and return. Okay, so here we also want to go backward. Like if I delete, so the way I go backward is first responder minus equal 1, right? But then we're facing a index out of range issue. If this is 0, then we go to -1, -1. That will crash the app. So we want to do a max here. First responder index. And if you think about it, it shouldn't -1 of the first responder. It should use the current index -1. Because if I'm hitting delete here, so I always want to go to here. So yeah, use index instead of first responder index. And we use max to get the larger one. So if this is negative, we always use 0. So we go back to the very first box. That's okay. And then we also handle the going back and forth here. So here it's because it's increasing, so we need to do a min here. And the furthest we want to go is index 5. So it should be count -1. and then index +1. Actually, it's not +1 because we can be typing or we can be pasting. So this should be string count. So let's think about it if this is correct. So if I'm pasting in 3 character, string count is 3, index is 0. So 3 and first should become 3. So if I paste in 3 and the cursor jumps here. Yeah, I think that's right. I can try. Paste. Yeah. So this logic here should be correct. And yeah, I think that covers all the scenarios. And I think our one-time code input looks completed. Well, at least it appears to be completed, but we can try, start using it. So we go back to this one-time code boxes. This is the SwiftUI view. And so now it's just the default. We want to embed in a horizontal stack. And we want a for each loop. Oh, we also need to pass the states done here. So we passed from content view into this SwiftUI view and then pass it down to each box. So first we need to get states here. And so for each, we just provide a range, say code count I, and then we just use the box we just created, one-time code input. So the index should be this I, and we just pass these states down. First responder. Okay. Now the preview is screaming. Let's pass in some default stuff. Just a constant. Something like 0, 1. This one comes in 0. Okay. So let's see if we can preview this. Okay, the Xcode wasn't cooperating, but now I got it work. So I can add like 4 digits. So it looks better. Well, it's actually rendering, but we can't see it because it has nothing. It just has white background. So what we can do here is I overlay it. We see a rounded rectangle. Corner radius, let's say 10. We don't want color, we just make it stroke. Line width 1. Okay. Now looks better. We also change it foreground color to secondary. Looks good, but it's taking too much space. So let's change this to only use the size it needs. Also add a little padding. Okay, now we need to fix this size issue. So if we want a square, we can use aspect ratio. Aspect ratio, say 1. Fit. Now much better. Much better. Okay. So we can even duplicate this and put it into dark mode. Looks good. and we can change this to 3. Still working. Pretty good. So now I think we can use this SwiftUI view inside our content view. So we replace this thing. So I just replace it one-time code boxes. Code digs, I just pass it down. Oh, look at this. Looks good. We also want to add some padding, maybe. Okay. Let's try if I can type here. 1, 2, 3, 4, 5. Delete, delete. Delete is not working. Well, we can see some interesting fact, like why delete in empty box, it does nothing. But why delete here, it actually can go back. So our code here is actually working. But let me demonstrate something. If I enter debug preview and I ping it here, and I put a breakpoint here. Why can't I type? Okay, maybe I'll just start it in the simulator. You can stop. Let's try start a simulator and try to hit this code inside the ace backspace. Let's see if it's hit. No, the breakpoint is not hit. But if I do this, interesting. So that's why we delete this is working, but when we hit backspace here, it's not working. Actually, I've mentioned this previously. The reason for this is because this method only gets called when the text is about to change. Well, when we are trying to delete this 3, the text will change from 3 to an empty string. But when we hit delete here, there's nothing to delete. So actually the text here is not about to change. So this method is not even called. So that's the reason why this doesn't get called, because this delegate method doesn't even get called. So that's why. And fortunately, I've came up with a solution for this. So what we are trying to achieve here is hitting delete key here can also go back. But how do we detect like the backspace is pressed? Well, there is a function inside UI text field called, I forgot what it's called, but we're going to make a subclass of it. So call it backspace text field, inherit from UI text field, and we can override that method. I think it's delete backward, override this. Yeah. So we want to do some custom behavior here. So let's call super delete backward first, and then we want to do our custom behavior here. So how do we do that? Well, we can pass in a closure, say on delete, and it's an optional closure. So by default, optional closures are escaping ones. So we can create initializer to pass in this closure. So I don't need to do escaping here. Actually, if I do this, it will give me some error, I think. Self home delete home delete. Yeah, closure is already escaping if it's optional, so I don't need this. And it's screaming at me, asking me to add this required initializer, so I just add it, that's fine. And super init is not called, so let's call it super init. Okay, so our UI text field subclass, backspace text field, is created. We can initialize with this initializer. So what we want to do is, instead of a basic UI text field, we use its subclass, a backspace text field on delete. And we do whatever we want to do to handle this case here. So what do we want to do here? We want to modify the first responder index. So because this is the go forward case, so we always want to make sure it's not negative. And we can do like this, I think. So basically repeat what we've done here. Let's run the app again. Okay. One. Delete. Delete. That's weird. It's not working. Okay. Don't forget to call this undeleted path-in closure. So let's run the app again. One, two, delete. Okay. It's going back. Okay. Seems we've achieved what we want. Let me just commit to get rid of these blue lines. Okay, what else? So we've composed boxes, and yeah, we want to add a Oncommit callback. So what that is, it's like once you finish typing the last character, it should automatically submit this code like to your server to check this code is right or something. Well, so that's onCommit. So to do that, we can easily achieve that by passing down a closure, onCommit closure, to this SwiftUI view, onCommit. So it's just a void closure. And because it's a struct, I don't need to do initializer or anything. And because it's a optional, so it has default value null, so it doesn't even break this current initializer. That's great. But we can add it on commit. And for now, I just print commit. But of course, we just passed it in doesn't mean it gets called somewhere. We need to pass it down one more level, like down to the box. So we pass it down one level. Oh, not on delete. commit. And because this is struct 2, so I don't need to modify anything. And when do we call this? I think we call that when our state becomes final, like when we have all 6 digits, then we can call this onCommit. So when our states change, this method will get called update UI view. So we can check here. What do we check? We say code dict values, and we want to filter out the empty ones, so not empty, and count equals 6. Well, we don't use hard code, we use code dict count. If this, yeah, what I'm doing here is I get all the values and I filter out the empty ones. So the remaining is values that not empty. And then I check if it's 6, and then this means all code boxes, all 6 boxes are filled. And so here I can call on commit. And of course I need to pass on commit from this to this, like down one more level. So on commit, and I just pass down on commit. So let's run the app again and see when we finish. 1, 2, 3, 4, 5, 6. Okay, it gets called 6 times. Well, that makes sense because we're passing it down to each box. So every box detects if 6 digits are filled, and they call on commit. So it's called 6 times. But you don't want to do this in the real world. It could mean you're sending 6 HTTP requests to your server, and we want to avoid that, right? But the good thing is, so like when we can finish this in any box, we don't have to finish the last box last. So we can just finish this box and it will detect if we've completed. Yeah, you can see it's printed. So that's a good part. So now the only thing we need to do is to avoid calling it 6 times. So I think we can do another check here. So I'll check if, yeah, I'll check this. So this means if I am the first responder, if this box, I'm the first responder, and then my state passes, then I call on commit. So other boxes, because they cannot meet this check, so other 5s won't call this. So only the first responder box will call this. So let's try again. Only called 1 time. Okay, that's good. So we have finished step 5, and we're approaching to the end. So finally, I will just do some cleaning up and do some minor change to optimize the appearance. So first of all, I'll delete the thing I didn't use. So I delete this, and now this I didn't use, and this I didn't use either. So I delete these. Okay. And also I want to add some visual feedback, like here. Bring up the keyboard. You see, once it's filled, it turns green. Well, it's not quite the same as what Apple does. What Apple does is it highlights the first responder box, but like we can easily achieve this if we can achieve this. So it's super simple to do this with SwiftUI. Let's do it. So here, inside here is where we define the border. Why it doesn't give me color? Well, it doesn't matter. We don't actually need the color. I can code without color. Yeah, so the foreground color. So if I change this to red, it will become red. So what I do here is I do a check, like I do a optional, not optional chaining. I don't remember how it's called, but I do a conditional thing here. So I check if this index box at in this index is filled. So how do I do that? Well, I can do code dict value at this index is empty. Well, of course, this is optional. Let is empty. Okay. So if the value is empty, then we get this is empty and use it to decide the color. So if is empty, then we use secondary color. Otherwise, we use green color. So how do we quickly test this? Well, I can give it a number here. Well, it's green. And yeah, we get instant viral feedback. I'll just keep it like this. Also, like when it's green, the border will get like bolder. So if it's empty, then it's 1. Otherwise, let's use 2. So yeah, when it's filled, the border, green border is thicker. So let's run again. 1, 2, 3. And if we paste in something, 1, 2, 3, 4, 5, 6, and we paste it in. Oh, I think I accidentally copied a paragraph thing. Let's try again. Delete and paste again. That's weird. Paste. Okay. Anyway, seems working. And oncommit gets called. Delete this. Fill in this. Oncommit gets called again. Okay, let's do a little more refactoring. So first thing of all, I've noticed we're not actually using this first responder index state in the content view, apart from just passing it down. So maybe we don't need to store this state in our content view because the content view is not actually using it. Just pass it down there. So maybe it should be just inside our one-time code boxes. So I just delete this and I delete this. I don't pass it down because it will have its own state. I change this to state. Okay. And the preview is not happy because I'm passing it in there, which I no longer need to pass. Okay. Delete those, see if still can preview. Build it. missing argument. Okay, because I didn't provide the initial value. So let's do it. Took longer, but it's actually working. Okay, so now we've moved that first responder index into this, so make the content view, the user, unaware of that. They don't need to know that detail. And the second thing is, I think sometimes we want to know the string type of the code, so we can extract the code from this dictionary and then send it to our server or do a validation or anything. So what we need is a string type of code, which can be a computed property, computed from the dictionary. So here I'll just first sort it, because dictionary doesn't have order, so it doesn't necessarily to be 0, 1. It can be like 5, 4, 1, 0, yeah, something like that. So I need to sort it first, and sort by key. So key, sorted by key. Okay, now after I sorted, it's an array of tuple, key and value. So I just want to have the value. So I map the key pass value. So after this, we get an array of string. Like we get this, and until 5 in order. So it's in order, so we can just join them to get our actual code. Okay, so here instead of printing this, we can print out our code. We can try running our app, but spoiler alert, it won't get printed for some weird reason. So 1, 2, 3, 4, 5, 6. Not working. So, but if I delete this and I type in something again, it gets printed out. So it seems like for the first time, the code dict is not updated properly, but after the first time, it's working. So I'm not quite sure why this is happening, but I've figured out a workaround to do this. So it's adding an onChange modifier, and whenever the code dict changes, we actually don't need to do anything in this closure. Just by adding this onChange will make it work. But we can just print the code dict to make sure every time we type something, it's changing. So let's try again. So 1, 2, 3, 4, 5. You can see the dictionary is actually updating. Yeah, it has the value. And when I finish the last digit, 1, 2, 3, 4, 5, 6, it's printed. So it's printed from here. And the dictionary is updated properly. So I'm not quite sure why this is happening. As I said, we don't need anything in this closure. But I think maybe because our custom SwiftUI view, it's like it's not updated based on the value of the dictionary. So after adding onChange, it just updates the code dict every time the inside code dict changes. Well, can't explain it very well, but this is the workaround. And as you see, we can print out this code. So what you should do is, instead of printing, you can send it to our to the server, or do some validation. So if anyone watching this video know why this is happening, please leave a comment, and I'll make sure to read through all the comments. And you can also give me some advice on how to improve my future videos. Also, I'll share a link of this project, of this repo on GitHub, and share the link in the comment area too. So you can just grab this and then use it like this in your project. Okay, let's finish this video by doing some summary. So during this tutorial, we've covered how to wrap a UIKit view using UI view representable struct. Like each box is a UI text field, and we make this whole widget using that wrapped UI text field, and then we pass the states down into this struct, and we've built like two-way communication to let the SwiftUI view to update the UI text field, and we also use coordinator to let the UI text field talk back to the SwiftUI view. So that's two-way communication. And we've also covered how to make your UI react to the state. Like the field box has green border and empty has secondary color. And also passing a closure into your SwiftUI view or even into your UIKit view is very simple. So as you can see, there's nothing fancy with this widget, and it's very reusable. Whenever you want to reuse it, this is all you need. Okay, so that's pretty much with this tutorial. Thanks for watching. It became much longer than I expected because this is my first time recording a video. It's a lot harder than I thought, and I probably need to do a lot of editing after I've finished. But here we are, and if it helped you in any way, feel free to like this video and subscribe. I probably will keep posting more tutorials like this. So once again, thanks for watching. See you next time.